Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the editorial director with Data Science Central and also chief data scientist for Data Magnum. I'd like to start off our event today by thanking Qubole for sponsoring today's event. Qubole is a valued supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some other recent sponsors, including Dell Statistica, Alteryx, Tableau, Microsoft, Exaptive, and Pivotal, to name just a few. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had an opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Today's webinar is entitled An Internet of Things, a Case Study, Using Big Data to Create Operational Efficiencies. Before we begin, I'd like to briefly review the format for today's webinar. Today's webinar will be an hour long. We'll have two presenters that I'll introduce in just a minute. There'll be a 10 to 15 minute question and answer period following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. You know, I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. You know, I'm very pleased to introduce today's speaker, Dr. Mohan Krisnamurthy with Qubole and Paul Asoyan with Google Cloud Platform. Now, Mohan has a background in mechanical engineering and controls and has worked with auto manufacturers and trucking fleets in improving fuel efficiency and reducing emissions. He was part of the research group at West Virginia University that conducted the emissions study exposing the Volkswagen scandal. So Mohan has a PhD in mechanical engineering from West Virginia University and an MBA from UC Berkeley's Haas School of Business. Now, Paul Asoyan is a strategic partnership manager with Google Cloud Platform, where he helps shape the future of how Google's cloud technology is used. His role is to develop and cultivate services and system integrator relationships with strategic partners in the United States and Canada. Paul's particular focus is the Internet of Things and big data. Now, prior to joining Google Cloud Platform, Paul managed strategic partnerships on Google Maps. He's been with Google for 8 years, where he previously helped build high-performing sales and channel business for Google Apps. But Paul's a graduate of the University of California, Berkeley, and holds a degree in political science. Thanks for being with us today, Mohan and Paul. We're looking forward to your presentation. The Internet of Things is touted with the potential to glean new insights and efficiencies by tapping into massive streams of data from sensors and machines. Now, driven by industry standardization, regulation, and the need for competitive advantage, the trucking industry became early adopters in onboard telematics and engine sensor data. Though this has generated volumes of data, most trucking companies have not fully capitalized on the wealth of business value in telematics data. This webinar will look at a case study that examines how IoT-based data can be analyzed and turned into insights that reduce cost and create operational efficiencies across the business using Google Platform and Qubole. In today's webinar, you'll hear from Mohan Krisnamurthy about data derived from the automobile and trucking industry. This data was then utilized to gain insights for fuel efficiency. And additionally, Paul Asoyan will share why Google Cloud Platform is the best place to build an IoT initiative, taking advantage of Google's heritage of web-scale processing, analytics, and machine intelligence. Mohan, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thanks, Bill. And thank you, everyone, for taking the time to be with us on this webinar. And let me give you a quick introduction about myself. This is what I look like, as you see in the picture. I am Mohan Krisnamurthy. I'm a Senior Product Manager at Qubole. As Bill briefly mentioned, I have spent a big part of my career looking at data analytics and data science, more focused on the auto industry and the trucking industry in particular, and helping fleets become more fuel efficient and helping engine manufacturers design engines and trucks that are more fuel efficient and more clean in terms of emissions. And data has played a big part in coming up to those better engines. And today at Qubole, I play a role in building a self-service data analytics platform that not only is going to help data scientists, but also data engineers and analysts to have easy access to data so that they can perform the analytics that can turn that data into business insights. But today we are going to talk about IoT. IoT spans a wide spectrum, and we are going to focus on IoT analytics in general and how analytics can turn that IoT data into business value. The business value of IoT is very wide-ranged. IoT is touted as a revolution in itself. It's because it brings about various changes. It has created new revenue streams, new products are coming out in the market. It has the potential to reduce your operational cost, make better use of your assets. But to me, this is also personal, right? Last night, I was going back from work and I was in an accident. 2 minutes later, I get a call from my wife asking if I'm okay. And this was possible because my car had an IoT device plugged into the OBD device. This device called my wife, who was on the emergency call list, and made sure that I was okay. And this is the kind of change that IoT can bring in a B2C environment, in a B2B environment. But is this change so easy to produce? There's definitely going to be some of those challenges. And those challenges are specific to the large data that the IoT is going to generate. Let's take a look at some of those challenges. If you are in the IoT business, you're providing a service, you are going to face with this large data. You have to make a choice as to choosing the right technology. But that technology is numerous in place, right? You have to make a choice and you have to make some upfront investment cost. That becomes a barrier in leveraging this data. And it's also going to change your business process. So those are some of the barriers that stand in the way of IoT and the IoT delivering its business value. But once those barriers are overcome, right? How do you leverage the data? You have to look at the right infrastructure that can play into the way IoT data comes up. It is going to grow exponentially. We are not talking about megabytes of data. We're now talking about petabytes of data. So choosing the right infrastructure becomes a very important choice. And choosing an architecture that is scalable, that can be optimized for cost. But not just that, it should be easy to implement and easy to administer. Once you made that choice, you're also not supposed to be locked into a particular vendor. And that is where cloud becomes a great choice and a perfect pairing for IoT and its data. So now you have the right infrastructure in place. So what do you do next? How do you turn this data into value, into insights? You ask the right questions. but questions come in various forms. As a data scientist, I have had the trouble dealing with the infrastructure, but once the infrastructure part was solved, I had to look at what kind of questions can I ask. I have to write some machine learning algorithms to understand or be able to predict fuel economy from trucks. I was looking into parameters that affect fuel efficiency, and that is a data mining question. So questions come in various forms, and your infrastructure should be capable of handling the variety of questions that go into determining the value in the data. So you ask the right questions, you get the answers, but does it end there? I believe you have to operationalize the data, and operationalizing the data is possible only if you develop the right metrics. In the past, I've looked at fleets to say that this has to be the fuel efficiency of the truck, and that becomes a metric to look into. In terms of driver behavior, is your driver driving at a particular speed? Understanding if speed is a metric that needs to be looked at. Acceleration could be another metric they look at. Hard braking was another parameter that has helped fleets in the past and from the data that I've looked at. Once you have these metrics, you have to build the right dashboard so that the user understands what changes can be made. Don't take my word for what it is. So let's take a look at Keras Mobile, which is a company that is revolutionizing the trucking industry. The trucking industry has been for a very long time and is now ripe for some disruption. And Keras Mobile is bringing the disruption into the market. But how? They provide a plug-and-play hardware device that is now the telematics platform for the trucking fleets. You simply plug this device into the OBD port of trucks that now collects the engine data and sends it for further analysis. But why is this important? The trucking industry has been collecting telematics data for a very long time. But the only piece of information that was being used was geolocation data. But today, with connectivity to the engine and the standard protocols that have been in place, there's more engine information that is being collected. Now comes the challenge of turning that information into insight. It is not just geolocation, it is understanding the health of the truck. How is your driver behavior affecting the fuel efficiency? Can I improve certain operations that is going to help my fleet? Or if you're a manufacturer, can I redesign my engine to be more fuel efficient? So taking this data and catering solutions that are particular to the user and the specific needs of the industry becomes very critical. One distinction I can see is if you are a large fleet, the needs of you mining the data are very different from a smaller fleet. So as a solution provider, you need to understand this difference. You need to be able to cater solutions that are very focused and so that the end user can derive the benefits of your insights. So Keras Mobile started as a telematics provider, but they decided to revamp their business model. So they started asking what additional value can Keras Mobile provide. So they started looking at how can you productize predictive analytics offering that can save fuel costs for their customers. Deriving insights that can help fleet managers be able to better predict maintenance frequency for their trucking fleets, as two of the examples that Keras Mobile provides. But they started also with an operational question. How can I minimize the time and effort it takes to deliver these insights? They also made a choice of using open source software. But as many of you know, maintaining open source software is not an easy task, and it is not user-friendly. They wanted to improve the productivity of their engineering and data science team, but eliminating the time spent on DevOps. They turned to Qubole and looked to partner with Qubole as a solution, because Qubole provides that scalable architecture by leveraging the elasticity of the cloud and provides an easy access to implement and administer the data through a well-developed user interface. Not only that, because of the cloud, because Qubole leverages the cloud storage and compute, they can easily deploy their product in days instead of months. And because Qubole is also a managed platform, Keras now does not have to worry about upgrades and changes in technology. Right? Each upgrade is automatically updated by Qubole, so Keras as an end user now has the flexibility to deal with the new updates. But how does Qubole do this? Let's take a look under the hood as to how Qubole leverages the elasticity of the cloud and separates storage and compute. The first part of the slide is the event producer, which happens in our case, in this example, is the truck that is generating data. This data from the truck's ECU is sent via a mobile device to a server. From there, the data is transported via an open source technology, which in this case is Kafka, to a storage location on the public cloud. If it is on the Google Cloud Platform, it is going to be the Google Cloud Storage. And now, as you can see, the elasticity part of the storage is handled by the cloud provider. As your data grows, you don't have to worry about adding new resources to store the data. The public cloud is going to take care of that. For the analytics part, this is where Qubole separation of cloud and compute becomes very important. As a data scientist, if I'm going to run a machine learning algorithm, I need to spin up a Spark cluster. I can come into Qubole's UI and with a click of a button, turn on a Spark cluster, import the data from my public cloud, run my query, and Qubole automatically will terminate a cluster when my workload or query is done. And in terms of once I have the results, I can now share the results through a user-friendly notebook where I can generate graphs which you can share with the rest of the group. And in Keras Mobile's case, they can share these as reports to their end customers. And that is the power of separation in storage and compute that Qubole provides. So using this infrastructure and leveraging Qubole, Keras now provides a central fleet analytics solution that helps fleet managers identify when they have to perform maintenance operations. As a driver, it gives me some metrics as to am I overspeeding, or what is in my driving behavior that is affecting fuel efficiency? What steps can I take to be a safe and a fuel efficient driver? The benefits go beyond just these. If you are a senior management looking at the fleet operations, you're going to look at ways to reduce costs further. One thing that pops out and becomes very prominent is insurance, which is about 30% of fleet cost. By being able to track your driver monitoring them for their driving behavior, now you have a better understanding of operations that lead to a safer fleet. This can in turn reduce your insurance cost. And fleets now work with insurance companies, and with this wealth of information are able to reduce the insurance cost and hence save money on the fleet operations. This is just one use case in one specific industry. The value of IoT is boundless, and the value of IoT data is even more. But you have to choose the right infrastructure, ask the right questions, and Qubole provides that infrastructure and an ability to be able to leverage the data to derive the insights that can turn this data into a business value. And now Paul will talk to you in detail about the Google Cloud and how Google Cloud helps companies in the IoT space leverage their offering. Paul?
Wonderful. Thank you, Mohan. Well, thank you very much, of course. And so my name is Paul. I work for Google on the Google Cloud Platform on the Google Cloud Platform team. And what I want to talk to you about is IoT, Internet of Toasters, as we jokingly say, but also Internet of Things, of course. So the reason why we're a little bit humorous with that is because IoT is everywhere, and we feel that it may have reached the higher peak of the hype curve. And everybody's talking about IoT. IoT is kind of the hottest thing out there, or one of the hottest things that everybody wants to know more about, but we argue that there is no consensus on what IoT actually is. So we argue that IoT is a concept that basically says that if a particular device is connected to the internet, but this is not our default perception of that device connected to the internet, such as, for example, watches. Watches are not connected to the internet by default, or washing machines, or toasters even. Then this is an IoT device. We don't really say Internet of Computers, because computers are connected to the internet by default. So that's our working definition of IoT. And it's understandable that it's a confusing concept. And also, it's understandable that's an exciting concept because numbers sort of support it, right? So we argue that there's going to be at least 20 billion devices connected by the year 2020. The economic impact of that is in trillions. It just once you're dealing with trillions, it's just very difficult to be precise with that. But it's very significant, right? And 54% of top performer companies will invest more in sensors this year. And the sources are cited below in general. So anytime when we're talking about billions, humorously, we should have Dr. Evil there. So it is a period of transition. As you remember, those flip phones were not connected to the internet, and then they sort of became connected to the internet, and now they are, in our opinion, out of the IoT period of transformation because all the phones are connected to the internet, right? So once you become connected, sort of, right, you become, you kind of remove yourself from the realm of IoT, but wearables and watches and cars are sort of connected, so we are in this very interesting period of transition. We argue that it is conceivable that we're in the midst of the fourth industrial revolution. And McKinsey agrees with us. They also say that there will be no longer a difference between information and materials because products will be inextricably linked to their information. And there is a lot of information there. But why build IoT? Information is everywhere, but it's not data yet. It's shocking how much information is out there that we're not leveraging or that we're unable to leverage for various reasons. Anything from the information within our houses and information in cities, retail, transportation, manufacturing, and healthcare has a tremendous amount of potential if we know how to wrangle this information and make perhaps predictions about what will happen in the future based on the past. So how do you collect and process this analog information to transfer into useful business intelligence? What's interesting is IoT comes to us through a different lens because we're used to digital information kind of being the digital native, originating in the digital format, whereas IoT information is analog that needs to be translated into the digital realm. And Internet of Things is the way to do this. So IoT is a new graph of how we connect with data as individuals in our day-to-day lives. We also argue that the Internet created the information graph that changes how we produce, access, share, and generate knowledge. Social media created the social graph that changed how we establish and foster relationships with others. The Internet of Things creates a physical graph that changes how we interact with objects and environments. So with all this hype and these tremendous opportunities out there, what has been holding people back? Well, it's obviously a very, very complex and challenging environment. There are a lot of moving parts here, everything from device hardware, everything from manufacturing that, to the device operating system, networking, mobile app development, data scale, security, and cloud app development. All of this needs to work in concert with each other. And each one of those circles by itself is quite the challenge. So there was a survey that was sent out from the World Economic Forum Industrial Internet Survey in 2014, when they've asked what's holding people back. And interoperability, of course, is number one, followed very closely by security, business case, legacy hardware, and so forth. But what we're seeing also on our side is an exponential interest in developing IoT solutions. So we feel that this is going to be an absolutely critical part of most businesses in the very near future. So just to kind of highlight what's holding companies back, it's the technical complexity, security and privacy, data challenges, cost, lack of standards. All of these are absolutely valid concerns. But why now is a great time for IoT? Well, tiny and cheap devices are more available. Complete Wi-Fi plus logic for less than $3. Cloud-backed data and processing. So large machine learning systems and petabyte scale systems now available on demand. And we're talking about a cent per gigabyte of stored cost. So foundationally, we feel like we're in an interesting time when all of these things are possible. So IoT at Google is basically resides around the Google Cloud platform and includes Nest and Brillo and Weave and Eddystone and on Hub, Glass, Android Auto, and Android itself. So we're going to chat about how all of these things connect with each other. So many of you are familiar with Nest, whether it's the thermostat or the camera or the smoke alarm. And it's basically a solution for the connected and thoughtful home. So it's interesting that these very disparate devices are going to be connected with each other. We also have Brillo and Weave, and we built it to help device makers build for IoT, create open ecosystems, and create opportunity for services. So what is Brillo? Brillo is an OS tailored for IoT to build a secure connected device and comes with services on analytics and update. And if you're interested in learning more, there is a URL on the bottom that I encourage you to check out. So Weave is a communications platform for IoT devices that standardizes device commands and state, facilitates user interaction from mobile devices and the web, and integrates with Google services. And also there is a URL on the bottom that I encourage you to check out. So Eddystone is essentially Bluetooth beacons to drive IoT solutions. There is a lot of interest in that. And it's everything from mobile payments to tracking and so forth. So this is something that we're also very interested in. So there's also Google iTap, which is a division within Google that's working on other things IoT as well. There is also Google X that's working on things that are IoT related, and one of the things that we can talk about is the contact lens that actually sends signals to your phone, signaling your state of health. And Google Fit, of course, is an application that I encourage you to check out as well. Basically, it measures how fast you've gone, run, and walked. And sort of one of our newest things is the router for the new way to Wi-Fi, and it's called OnHub. So also encourage you to check that out. So essentially, I apologize. The newest device that we have is Google Home, and that's a device that you can control with your voice. So Google, in our opinion, is uniquely positioned to take advantage of the IoT opportunity out there. We have software engineering, security, site reliability engineering. We have folks who work in privacy and in the UX realm. And sort of our focus is on the user. We have a bias for open, culture of innovation, and world-class infrastructure. And I think all of this is a wonderful foundation for us to be successful. We also do collaborate with a lot of universities, and the resulting open ecosystem should facilitate experimentation with application and user experience, ensure privacy and security, develop systems that guarantee interoperability. So how does IoT relate to Google Cloud Platform is something that I'm particularly excited to talk about. So we feel that a data center is not a collection of computers. A data center is a computer, and we're very well known for our technical infrastructure. So one of our edges is that we run an incredible distributed technical infrastructure. We have 70 edge locations in 33 countries, and it's the broadest reaching network of any cloud provider. And Google Cloud Platform gives you a pretty comprehensive look into what is important. It's compute, it's networking, it's big data, it's operations, storage, mobile, and developer tools. So Google research in data technologies is by no means new. So many of you know that we have published a white paper called MapReduce that later became Hadoop. We also have a lot of interesting technologies that should be familiar to most of you, including Bigtable, for example, as well as perhaps PubSub. And as products on Google Cloud Platform, what we have done is we have taken internal tools that we've been using for a long time and made them into enterprise-grade solutions. So Bigtable, for example, Bigquery, Dataflow, cloud storage are some of the things that should ring a bell. So I want to focus for just a second on Bigquery, just because it's center stage for not just collecting a tremendous amount of data, but analyzing that data, which is one of the more challenging things out there. So what is it? It's a fully managed, no-ops data warehouse. It is petabyte scale and fast. It offers the convenience of SQL, and it's essentially an externalization of Google Dremel. So something that we have worked on for many, many years is now external to our customers. Why do we feel that it's a compelling solution in the IoT realm? It's an independently scaling compute and storage, scales in seconds, easy multi-tenancy and unlimited resources, and it's a consumption-based model, so you're not prepaying. Unlimited compute is really critical here, just because of the vast amount of data, something that Mohan alluded to multiple times. There is a tremendous amount of data in the IoT realm. So workloads cannot be competing for finite resources if you want to be successful in the IoT realm. No starvation of resources due to a bad job, and no resizing clusters for more resources. Unlimited storage. So storage is also incredibly important. The reason for that is the first question that we get asked is, so fine, we're going to be able to collect all this information. How do we store it in a secure fashion? And how do we store petabytes upon petabytes of data? So you don't need to throw anything away or archive all data, because you can make amazing predictions based on the corpus of data, and the bigger that data is, the better off you are, with all things being equal. So store everything accessible by SQL immediately, and it's basically flat 2 cents per gigabyte per month, and that price may be a tad old because we do change our pricing all the time, and it's getting cheaper and cheaper with time. Consumption-based model, obviously, so you're not really prepaying for anything, and it scales with your use. So let's run some stats for complex query. And this is, I think, also maybe slightly dated, just because our resources, our computing resources, are getting much faster. So execution time is 11 seconds. Data scanned 4 terabytes. And if you wanted to measure 100 billion, and data shuffle 278 gigabytes. So it's pretty incredible what is happening now and what can happen in the next 2 or 3 years. Security is one of the most important aspects there, and we feel that ours is certainly a standout. So as far as people are concerned, we have more than 500 top security experts on staff. We care a lot about the physical security piece, and we do offer full stack. So we have the top 5 server manufacturers. We build everything, hardware, custom software stack. Full stack ownership greatly reduces attack surface, of course, and live migration keeps you running while we patch. Quick case study on Google enabling IoT. So Nest is something that you're already familiar with, and it's sitting on the Google Cloud Platform. There's Hue architecture and Google Container Engine. There's Acclima. And there is monitoring goods in transit using PubSub with Eddystone beacons. So if I had to briefly say why Google for IoT, it's the speed of insight, Google's global network, broad footprint across the IoT reference stack, innovation, security, pricing, and of course 15 years of know-how building the world's largest supercomputers and processing enormous amounts of data. That's all I have. Thank you.
Okay. Well, Mohan, Paul, thank you so much for that excellent presentation. We'll get started with today's Q&A session. And I want to thank the audience for their participation. We've had a great many questions that have come in during the presentation, and we'll do our best to get through them all during the time remaining. So during the Q&A session, I'll leave up this screen with contact information for Mohan and Paul. And if you'd like to contact them during following today's webinar. So let's get started. Mohan, Paul. If I am a company that is contemplating getting into IoT, I have a choice to make about whether or not this is going to be in the cloud or on premises. Can you tell us what the decision criteria would be for making that call, and what are the advantages of running this in either environment?
This is Paul. I can point out a few things, and I would love for Mohan to chime in as well. But we firmly believe that leveraging computing power of Google or, frankly, another cloud provider is something that cannot be matched on premise. Secondly, the pace of innovation that Google and other cloud providers are known for will enable you to leverage the latest technology in the cloud. And, of course, the security piece. We feel that security is sort of a moving target, and if you have security in the cloud, then it can happen much faster, and this will enable your solution to be more secure in the cloud. And of course, perhaps the last thing is the scale, right? So if you want to scale your solution on premise, you're going to have to plan for data center expansion, servers, and so forth, whereas in the cloud, it scales as you go.
One thing I would like to add to Paul's comment is also the ad hoc nature of analysis, right? As a data scientist, I think of a query. I want to be able to run the query. And when the query is done, you want your compute instances to be turned off, right? I do not, if I am on-prem, I have to be able to plan what is my workload, and I need to be able to make the infrastructure decision up front. But with the cloud, you have this on-demand instances that you can create where you can run your query, bring down those instances when your query is done. I think that's another powerful feature that the cloud provides.
Terrific. Well, thank you for that answer. You know, here is I think a point of confusion that we've probably brought on ourselves in this era of talking about big data and streaming analytics. If I can already do real-time analytics, why do I need big data analytics?
Bill, could you repeat the question, please?
Sure. If we are already doing real-time analytics, why do I need big data analytics? Why are big data analytics needed if I can do real-time analytics already?
The way I understand is real-time analytics provides definitely a lot of value in IoT. I gave you an example of a real-time alert. I was with a solar company where monitoring the system was very important. So, for example, if the solar panel or your power plant is not producing the right amount of output, you generate that alert. You're continuously monitoring. But there's also value in what I refer to as the cold data. You're collecting this large amount of data that is stored in a central place. It gives you a historical analysis that is equally important. In the case of a solar power plant, it was very critical to know the weather conditions, the weather patterns in a particular location before deciding on where the new power plant should go. So yes, real-time offers benefits, but it is also there's other information that can be mined out of the data that is collected over time. And hence, having this infrastructure in place becomes very important.
I agree with Mohan. This is Paul, by the way. We feel that not only big data analytics is certainly the future of IoT, but especially it's powerful. Just to drive Mohan's point is if you harness the power of machine learning on top of it, that will be able to help you predict future events with tremendous accuracy. And of course, for that, you need big data.
Well, thank you. Thank you for those answers. I'd like to get at the broad question of, what are the major benefits of running big data analytics on IoT events? But let me give you some specifics as well, because we've had questions come in about whether or not or how to get those benefits, for example, for recommenders or for studying usage patterns, for example, for upselling. So perhaps you could focus on those as well as just talking about the broader benefits. Anybody want to take that one?
This is Paul. I just want to make sure that I understand the question fully. How do you harness the power of IoT to generate more business? Is that the question, you think?
Well, generally, what are the benefits of running big data analytics on IoT events? And then the audience has asked for specific examples relating to upselling and recommenders.
Well, I can cite an example. I may be biased in this. I'm going to use automotive as an example. There are companies such as Verizon's Hum, Automatic is another company, and there's another company called Mile IQ. So these are companies that are new business models in the automotive space. They provide you with these dongles that you can connect to your car. They are collecting data as you drive. They're collecting information about your driving behavior, the routes that you normally use, right? Using this data, they are able to create data products where now they have multiple customers that they can sell this product to. One example is Automatic now works with, for example, insurance companies in providing information about their customers and how drivers are driving in various geolocations. This helps insurance companies to create risk patterns in certain locations. Right? This is information that the insurance company did not have earlier. Now, using this data, they get better understanding of driving behavior of their customers. So these vendors they also now have information about the cars itself, the fuel economy of these cars. Now they can package this information and sell it to the car manufacturers itself. So it is just one source of data, but now it is catering to different customers and generating revenue streams for these customers. I'm sorry, the vendors. So.
Okay, well, hey, thank you for that answer. And Mohan, as a fellow data scientist, I have to ask a simple question. That is there any restriction on the analytic languages that I can use in Qubole? Can I use, for example, R to take a real simple one?
As a data scientist, I would say yes, absolutely. Qubole now only provides R. Through our notebook interface, data scientists or anyone who wants to run analysis in R can use and run R on Qubole. I'd like to add that it is not just R, but Qubole provides access to other languages of your choice. You're seeing a growing number of data scientists use Python as their choice, which can also be run within the Qubole environment. And now you're also seeing Scala become a choice for data scientists and analysts. So Scala can also be run within the Qubole environment. So now we provide that choice, and now you can run your analysis the way you normally do within the Qubole environment.
Terrific. So really no practical restrictions at all. It'll handle all of my data science needs and make it simple for me. There are still some barriers that people have in their minds about moving their data onto the cloud. Certainly one of them is security of the data. So what guarantees can you provide for security of the data? Are there certifications or transparency? Are there bodies of compliance practices? How do you deal with questions about data security?
This is Mohan. So within Qubole, so we are strictly on the cloud in a sense. We leverage the public cloud. So we've taken security very seriously, and we are constantly improving our security features, and we are compliant for SOC 2. And also we are working towards HIPAA compliance as we see a growing customer base in the healthcare industry.
Terrific.
And this Paul, I just wanted to point out on the Google Cloud Platform side of the house, we have a plethora of certifications, but the one that are perhaps the most relevant are SSAE 16 as well as ISAE 3402 Type 2. SOC 2, we have the SOC 3 public audit report available to anybody, as well as ISO 27001 and other ones, as well as PCI DSS version 3.1. Google Cloud Platform will also support HIPAA-covered customers by entering into a business associate agreement, the so-called BAA. The Cloud Platform BAA currently covers Compute Engine, Cloud Storage, Cloud SQL, Genomics, and Bigquery.
Paul, thank you. And I noticed on one of your slides you mentioned as one of the barriers, not a real barrier, but a perceived barrier, are concerns about standardization. Is there a particular organization or set of standards that's in the lead right now? Where's the industry headed on standardizing inputs?
I think that this is perhaps the most contentious point. We have not seen a strong leader there, but we do feel that in the very foreseeable future, my opinion is 6 to 12 months, we're going to see some sort of sanitization. And it's difficult to predict who is going to emerge victorious, so to say, in this, but it is a great question and a question that is not resolved in its finality yet, but we do feel that it's going to be resolved very soon. Yeah,
in such tumult in this industry, I certainly agree with you. It's going to have to arise. Mohan, we have a question. You talked about your work in optimizing fuel efficiency and that sort of thing with your truck manufacturer. How did it turn out? Were you able to reduce maintenance? Can you give some quantitative scale to that? And can you talk a little bit about the machine learning algorithms and statistical models that you use to get your results?
Yes, sure. One example I can think of is when I worked with a fleet in Reno. They make daily trips to Port of Oakland in California. The optimization we looked at was, given the route that they take, and it's a daily route that they take, we were able to see differences between their drivers as to what contributed to more fuel consumption. And I briefly mentioned this during my talk. We looked at, so the parameters that stood out was the vehicle speed itself, which I think it's a fairly straightforward to assume vehicle speed has an impact on fuel efficiency. But what speed should the driver drive? Is it 55 miles per hour? Is it 60 miles per hour? So when we looked at the kind of engines in their truck and the load that they carry, so they're most likely carrying a fully loaded truck when they come from Reno to Oakland. They empty their truck and they're running an empty load sometimes from Port of Oakland to back to Reno. So understanding, by looking at these various operating conditions, we noticed that for condition 1, which is, say, if they're fully loaded, a speed of, if they keep their speed between 50 and 55 miles per hour, they got the most fuel efficiency. But when they are driving an empty load, the speed was slightly different. And when they're carrying a different load, for example, if it's a half-loaded truck, the speed that we looked at was very different. So it's easy to use averages, but it's only when you go down to the granularity you get the most benefit. And you had asked an earlier question, so why is the historical analysis important? It is to wean this kind of information, you need to look at the historical information. And to give you the result of this analysis, this fleet in Reno was able to reduce their fuel efficiency or increase their fuel efficiency by 5%. 5% to a regular user who is just a car driver, it is a very small number. But for a fleet that runs, for a single truck that drives about 100 to 200,000 miles a year, that 5% translates to huge cost savings.
Well, it's always great to hear real outcomes on these studies, and particularly when they're as positive as that one was. Obviously, that was a huge cost savings for those folks. Well, Mohan, Paul, thanks for some great answers to some very good questions. And for those of you that asked questions that weren't answered today, we'll be sending all the unanswered questions to Mohan and the Qubole team so they can follow up with you today after today's webinar. You know, I have just a few quick announcements. If you'll please mark your calendars for June 21st, and that's our next DSC webinar, which is Enhanced Predictive Modeling with Better Data Preparation, and that'll be sponsored by Alteryx. Also, today's taping will be available for on-demand viewing later today, and you can find that on the homepage of datasciencecentral.com in the webinar tab, which is located at the top of the page. Well, this brings today's webinar to a close, and I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Qubole for their sponsorship and our speakers today, Mohan Krisnamurthy and Paul Asoyan, for their insight into today's topic. My name is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on June 21st. Have a great day.
Thank you. Goodbye.